Hi, my name is MALVINA LUDAN, CN180134. My project supervisor is Dr. Hanizam Bimadon, and today I'm going to present about development and optimization of green zinc oxide nanoparticles using Cymbopogonidus extract. First, I will talk about the introduction of this research. I will talk about zinc oxide. First, zinc oxide is promising as heterogeneous photocatalyst material for photocatalytic reaction due to a wide range of properties. Next, it is high photosensitivity, which causes degradation of various pollutants made in potential photocatalyst material. Next, it has band gap, which is 3.37 eV, and large excitation binding energy, which is 60 MeV. Lastly, it has high stability, a low cost production, and is insoluble in water. As for the problem statement, so there's a lot of publication on green synthesis of zinc oxide nanoparticles and plant extract. For example, recent research was synthesized zinc oxide nanoparticles using leaf extract of Cassia fistula and Melia azurec by NASA in 2020, and the performance of membrane photocatalytic reactor incorporated with zinc oxide Cymbopogon in treating palm oil mill secondary effluent by Abu Bakar Siddiq in 2020, where the researchers used Cymbopogon leaf extract. Unfortunately, there was no studies that are based on Cymbopogon extract. Therefore, this is why this research was conducted. This gap in research has become highest motivation for pursuing this project. Thus, the development and optimization of green zinc oxide nanoparticles using Cymbopogon extract theoretically appropriate to cover the research gap created by the problem argument. There are several aims in order to answer the research question. First, what is the ideal extraction temperature? Second, what is the optimum retention time for extraction? Third, how many concentration of Cymbopogon needed to be synthesized? Next, what is the best doping method to choose? Next, how many solvent needed to use? And lastly, what is the quality of synthesized nanoparticles? There are three research objectives. First, to extract the Cymbopogon by using solid liquid hydroextraction and characterize the extracted concentration. Second, to develop and optimize the variable for green synthesis nanoparticles using Cymbopogon extract. And lastly, to characterize the formula zinc oxide Cymbopogon nanoparticles. So we talk about research scope. The scope of Objective 1 and Objective 2, which is synthesis of zinc oxide Cymbopogon nanoparticles. First, the Cymbopogon leaf is extracted using conventional heating with water as a solvent at moderate temperature, 80 degrees Celsius. Second, the zinc oxide nanoparticles are synthesized via precipitation method under different ratios of zinc oxide solution and Cymbopogon leaf extract. Zinc oxide nanoparticles is synthesized via precipitation method using Cymbopogon extract at variety of different concentration of 1%, 4%, and 8%. And lastly, the optimization will be using response surface methodology RSM. The variable will be the reaction time, pH, and the plant extract concentration. Next, for the research scope of Objective 3, evaluation of characteristic of formulating zinc oxide Cymbopogon. First, characterization of zinc oxide Cymbopogon nanoparticles using field emission scanning electron microscope (PSM) in terms of surface morphology. Second, using Fourier transform infrared spectroscopy (FTIR) and characterization of zinc oxide Cymbopogon nanoparticles using X-ray diffraction in terms of crystal size. Next is significance of the study. First, The new field of research, synthesis of zinc oxide nanoparticles using simple leaf is a fairly new field of research which is able to reduce the amount of waste going to the landfill. Next, act as capping agent. The biological compound present in the simple leaf extract leaf responsible as a capping agent to minimizing the agglomeration and reduce the particle size of zinc oxide nanoparticles. Next, well-known on basis biological activity, which is therapeutic, cosmetic, food preservation, and agriculture. And lastly, the utilization of plant as a substitution of chemical feedstock to synthesize metal oxide nanoparticles, which with high quality might contribute to the economy at commercial scale. So I will talk about literature review of this research. Zinc oxide nanoparticles form a major part of medical and agriculture industry due to their possession in antimicrobial activity. And the table shown characteristics of zinc oxide in particular. Zinc oxide nanoparticles has been widely exploited for their photolytic properties and finding extensive application in personal care products because of their ultraviolet blocking ability. The crystalline has the woodside crystal structure, having hexagonal unit cell with 2 lattice parameter, and in this woodside hexagonal structure, each anion is surrounded by 4 cations at the corners of the tetrahedron, which shows the tetrahedral coordination and hence exhibit the covalent bonding. The tetrahedral configuration of zinc oxide gives rise to a non-centrosymmetric structure as shown in the figure. Green zinc oxide nanoparticles developed as an approach to avoid the drawbacks of synthesis by conventional methods, which were found to be more expensive and involve the use of toxic and hazardous chemicals. In green synthesis, plant parts like roots, leaves, stems, seeds, fruits are used for the nanoparticle synthesis as the extract is rich in phytochemical, for instance, polysaccharides, polyphenolic compounds, vitamin, amino acid, alkaloids, and terpenoids, which act as both reducing and capping agents. Plants are so preferred because they lead to large-scale production of stable, varied in shape and size of nanoparticles. Synthesis of green zinc oxide nanoparticles. The effect of reaction time. The influence of synthesis temperature and reaction time on the structure and optical properties of zinc oxide nanoparticles synthesized by the hydrothermal method was investigated using X-ray diffraction, FTIR, and PSM. Next, the effect of pH. It affects the size and antibacterial activity of the zinc oxide nanoparticles. Lastly, effect of plant extract concentration. The plant extract concentration gives an effect to the size of the nanoparticles, the crystallite size, and the homogeneity of zinc oxide nanoparticles were influenced by the amount of extract during the synthesis. The Cimopogonides belong to Penicodia family of gramineae and well known as one of the traditional medicinal plants. Cimopogonides plant is a green and purplish red stems, green leaf, color to bluish green, flat elongated, leaf resembling to reed, and if the leaves are squeezed, it will smell a distinctive aroma. Next, I will talk about the response surface methodology. RSM is a practice for developing and optimizing process, whereas it is a collection of statistical and mathematical approach. It provides foremost application in the design and development of the new products. Using this software, we can explain the relationship between the response and the independent variables. In this research, the collective effects of factors were obtained in order to statistically construct the response surface. In this research, there will be three parameters will be used, which is first, the reaction time, 2 to 6 hours. Secondly, the concentration of plant extract, Cymbopogonidus, 1 to 8%. Lastly, the pH of zinc excited in deionized water, 8.0 to 12.5. Next, I'll talk about the comparison of related work done by the previous researchers on optimization study of green zinc oxide synthesis using response surface methodology. There are three related work by the previous researchers where the use method of optimization are response surface methodology, response surface with CCD, which is centrous composite design, and the response surface methodology with box Behnken's design. So we talk about the methodology of this research. It's shown the flowchart planning of this research. It starts with gathering information, selecting the parameter, and identification of title, problem statement, objective, and scope of this research, and characterization method selection. And lastly is proposal writing. Design of experiment. It will be formulated using Central Composite Design (CCD), since it can build a second-order model after analyzing the data collection with minimum experiment. The three variables that will be used in this research, which are pH, reaction time, and concentration of plant extract. Phase involved in this research. First phase, which are simple preparation and experimental process. Second phase is characterization of green zinc oxide Cymbopogonidus nanoparticles using XRD, PSM, and FTK. And the third phase is analysis of optimization. As for the expected outcome, the optimal synthesized zinc oxide Cymbopogonidus will enhance the band gap in the near UV spectral region. After that, it will increase the stability at a low cost production, enhance the instability in water. Next, enhance the surface area to reactant volume ratios. However, this research must be performed and tested physically to find the most optimal condition of zinc oxide with Cymbopogonidus. The Gantt chart of the research is start with discussion with supervisor. Next is preparation of research proposal, and lastly is preparation for report presentation. These are the list of the reference that are used in this research. These are the list of reference that are used in this research. That's all from me. Thank you.